Hello! Yes, and welcome to our Objective 2.8 sample problems. Objective 2.8 says I can solve right triangles. So today in these sample problems, we're going to spend our time solving some right triangles. So let's start here with letter A. Remember that when we solve triangles, we want to be able to list the measurement of every angle and every side. So let's go ahead and identify what we know and what we do not. So angle A, they give us to be 38 degrees. Angle B, we do not know. Angle C is 90 degrees. Side A, we don't know. Side B would be 15. Remember that this is side A, this is side B, and our side C would be our hypotenuse. We also don't know that. Okay, so let's start by identifying the angle we're missing. So remember that for angle B, we can do 180 minus 38 plus 90 because the interior angles of a triangle have to add up to 180. So on my calculator, I'll do 180 minus parentheses 38 plus 90, close parentheses, and I get 52. So I know that angle B is 52 degrees. So now that I have all my angles, let's look at my sides. Let's go ahead and start with side A. So if I'm dealing with angle A that they give us here, side A would be my opposite side, and side B would be my adjacent. So I'm going to use tangent. So I'll say the tangent of 38 degrees equals my opposite, which is side A, over my adjacent. Side B is 15. So that means that A would equal 15 times the tangent of 38. Put that in my calculator. 15 tan 38, close parentheses, 11.72. Fantastic. Now to find side C, that's the hypotenuse. So we're dealing with the adjacent and the hypotenuse. So I forgot the letter P in there. Adjacent hypotenuse, that would be cosine. So I would say the cosine of 38 degrees equals my adjacent, 15, over my hypotenuse, which is side C. That tells me that C will equal 15 divided by the cosine of 38. In my calculator, 15 divided by the cosine of 38. And that is 19.04. And there we go. We have solved our triangle ABC. All right, looking at letter B. Let's go ahead and, well, I see right here that we don't know angle A or angle B. We do know that angle C is 90 degrees. But we do know side A is the one side we don't know. We know B is 11 and C is 13. So we're going to have to use some inverse trig here, aren't we? So let's start by identifying angle A. So if I want to do that, this would be my adjacent side and my hypotenuse that I'm given. So I would use cosine. So I'd say cosine inverse. Again, this is for angle A. Cosine inverse of adjacent 11 over hypotenuse 13. So I can say second cosine inverse of 11 divided by 13 equals 32.20 degrees. Very good. And to find angle B, think of this now. So if I'm looking at this angle, this would now be my opposite side and my hypotenuse. So I would use sine. So I would say sine inverse of 11 over 13. So let's go ahead and do that. Sine inverse of 11, oh, that's 1. 11 divided by 13, close parentheses, we get 57.80. Now notice, we know we did this right because these two add up to 90 degrees, which would make our total, all of these angles, add up to 180. So that's how we can tell we're on the right path. Now to figure out side A, we can use Pythagorean's theorem. So we'll say a squared plus 11 squared equals 13 squared. So a squared plus 121 equals 169. 169 minus 121 is 48. So a squared will equal 48. So that means a will equal the square root of 48. So I'll say second, the square root 48, close parentheses. Actually, I don't even need parentheses. And we get 6.93. There you go. Notice a cool relation. The smallest angle will correspond to the smallest side, and so on and so forth. The largest angle, the 90 degrees, corresponds, of course, to the hypotenuse, which will always be the longest side. So there are our measurements for triangle ABC. Let's do a couple more of these. If you want to pause the video and try them on your own to see how you do, you're more than welcome to. But if you want to just continue on with me, let's go ahead and try to solve this triangle ABC. So angle ABC, sides A, side B, side C. We do know that angle C is 90 degrees. We do not know angle A or angle B, so that tells me we're going to be using some inverse trig. We know side A, actually that's the one side we don't know. We know side B is 5 and side C is 14. Fantastic. Okay, well, let's figure it out here. So if I want to figure out angle A, this would be my adjacent, this would be my hypotenuse, so I'd use the cosine. So I'd say for angle A, the cosine inverse of 5 over 14. So second cosine inverse, 5 divided by 14, close parentheses, 69.08. And to find angle B, I would use sine inverse of 5 over 14 because this side for angle B would now be my opposite, right? If I'm dealing with this angle, this is now the opposite side. So sine inverse of 5 over 14, close parentheses, 20.92 degrees. Fantastic. All right, now to figure out side A, Pythagorean's theorem once again, we do a squared plus 5 squared equals 14 squared. Of course, recall that 14 squared is 196. So we'll say a squared plus 25 equals 196. Subtract 25 from both sides. 196 minus 25 is 171. Take the square root, of course, which tells me that A will equal, what is the square root of 171? 13.08. Fantastic. Well done, well done. And now we have one more where they give us the image for the triangle we're trying to solve. So let's do letter D here. So angle A, we do not know. We do know that angle B is 52 degrees. Angle C is 90 degrees. We do not know side A or side B, but we do know that side C is 3. So since 3 is the hypotenuse, both of the side lengths that I'm going to be dealing with for A and B will be smaller than 3. So let's start by figuring out angle A. So angle A will be 180 minus 90 plus 52. In my calculator, 180 minus parentheses 90 plus 52, close parentheses, enter, 38. So A is 38 degrees, very good. And then I can go ahead and find side A, which would be this side here. So if I'm using angle B, and it's always good to use the angle they gave us, just in case we make an error on calculating the other angle. So that would be the adjacent and the hypotenuse. So that means I'm using cosine of 52 degrees equals my adjacent over my hypotenuse. Okay, so that would mean side A would be 3 times the cosine of 52. 3 cosine 52, close parentheses, 1.85. Very good. Side B now, if I want to use that same angle B, so now I would do sine, because that would be my opposite side. So sine of 52 equals B over 3. That means that B would equal 3 times the sine of 52. And 3 times the sine of 52 equals 2.36. Awesome. And there are our angle measurements for these two triangles that we just solved. Well done. All right, now let's look at, if they don't give us an image, let's see what we can do on our own. So first up, angle number A, letter A, sorry, where triangle ABC is B equals 9, A equals 27, C equals 90. So again, I just draw a triangle. Any triangle is fine. I do know that this will be side C. We'll call this A. We'll call this B. I know that A is 27 degrees, C is 90, and side B, which would be this side at the bottom, is 9. This would be side C. This would be side A. So we know that angle A is 27 degrees. We do not know angle B yet. We know that angle C is 90 degrees. We do not know side A. We know that side B is 9. We do not know side C yet. So let's start by figuring out our missing angle. So for angle B, I would say 180 minus 90 plus 27, parentheses 90 plus 27, and I get 63. So B is 63 degrees. Fantastic. And now let's figure out side A. So this would be my, if I'm dealing with angle A here, this would be my opposite and my adjacent. Okay, opposite and adjacent tells me I'm going to use tangent. So I'd say the tangent of 27 equals my opposite A over my adjacent 9. So that means that A would equal 9 times the tangent of 27. So let's put that in our calculator. 9 tangent 27, close parentheses, 4.59. That makes sense. Now, to check our work, C would need to be bigger than 9, right? Because it's the hypotenuse that should be the largest side. Now, that is, of course, the hypotenuse. So if I'm using the adjacent and the hypotenuse, I'd use cosine of 27 degrees equals my adjacent 9 over my hypotenuse C. All right, so that means that C will equal 9 divided by the cosine of 27. 9 divided by cosine 27, and I get 10.10. Haha, it is bigger than 9, so I can go ahead and be pretty confident with my answers for that one. Well done. All right, let's look at letter B here, triangle XYZ, where x is 6, z is 8, and side z is 8, and angle z is 90 degrees. So let's go ahead and draw a picture here. We know that this is angle z. We know side z is 8, and it doesn't really matter otherwise. We can say this is 6, and that means this is y. This would be side y. We don't know that one yet. Okay, let's go ahead. And, well, let's list what we know. We do not know angle x. We do not know angle y. We do know that angle z is 90 degrees. We know that side x is 6. We do not know side y. We know that side z is 8. All right, so let's do some inverse trig here. So if I'm wanting angle x, this would be the opposite and the hypotenuse. So I would do sine. So to find angle x, let's do the sine inverse of my opposite 6 over my hypotenuse 8. So second, sine inverse, 6 divided by 8, close parentheses, 48.59 degrees. Very good. And for y, this side x would be the adjacent side. So I would do the cosine, right? So this would be the cosine inverse of 6 over 8. So second cosine inverse 6 divided by 8. And we get 41.41 degrees. Fantastic. Now to find side y, we can use Pythagorean's theorem. So we'd say sit squared plus y squared equals 8 squared. So 36 plus y squared is 64. 36 minus 64, 64 minus 36 would be 28. So that means y will equal the square root of 28 in our calculator. Figure out what that equals. It's going to be just a bit more than 5, I would say. 5.29. And there we go. there is our solved right triangle. We know all the angles and all the sides of this triangle now. All right. A couple more. If you want to pause the video and do them on your own and then check, you're welcome to. Otherwise, let's go ahead and dive in here. So we have ABC, where A is 6, angle B is 55, angle C is 90. All right. Let's draw a triangle here. I know that this is C. We'll call this B. We'll call this A. So that means this is 55 degrees. Side A is 6, and that's all we know. All right, so let's notate what we know. Angle A, we do not know yet. Angle B, 55 degrees. Angle C is 90 degrees. We know that side A is 6. We do not know side B. We do not know side C yet. All right, to figure out angle A, well, 180 minus 90 plus 55. Do that in our calculator. 180 minus, parentheses, 90 plus 55. We get 35 degrees for angle A. Fantastic. Now let's figure out side B. So that would be this side here. This would be the opposite of the angle we were given. So we also know the adjacent. Opposite and adjacent would be tangent. So to figure out side B, we'd say the tangent of 55 equals my opposite, B, over my adjacent, 6. Multiply both sides by 6. That tells me that B will equal the tangent of 55. Or sorry, 6 times the tangent of 55. So 6 tangent of 55, close parentheses, 8.57. Very good. And to figure out side C, our hypotenuse, we would be using our adjacent in our hypotenuse. That's cosine. So I'd say the cosine of 55 degrees is my adjacent, which is 6, over my hypotenuse, which is C. C will equal 6 divided by the cosine of 55 then. 6 divided by the cosine 55, close parentheses, 10.46. And there we go. There is everything we need to know about this triangle. All right, last one. Letter D, JKL. Side J is 9, L is 8, and angle L is 90. This is a fun one. All right, and I saved this for last intentionally. Let's see if we can catch it. So angle L, 90 degrees. Side L is 8. Side J, we'll call this J, is 9, which means this is K. So let's identify what we know. We do not know angle J. We do not know angle K. We do not know, we do know angle L. It's 90 degrees. We do, side J is 9. Side K we don't know. Side L is 8. So let's start by identifying our angles. So angle J, we would say is, let's see, this would be the opposite in the hypotenuse. So sine inverse of, my opposite is 9, my hypotenuse is 8. So second, sine inverse of 9 divided by 8. Error. All right, now we've probably realized what's happened here. All right, notice the length of our hypotenuse, 8. Remember that our hypotenuse has to be our largest side. What do you notice here? This side is 9. Okay, so that means that it's impossible for there to be a triangle with these dimensions. It's impossible to have our largest angle, 90 degrees, opposite a side that is not our largest side. So what does that mean? That means that this triangle has no solution. It cannot be solved. All right. Hopefully that helped you. Okay, that was a good set of sample problems. I think we really covered a lot of content there. If you have any questions, as always, feel free to reach out. Otherwise, go ahead and get started on those practice problems. This is Mr. Carter signing off. I'll see you next time.